All right, this is the 2023 Calculus BC Exam FRQ number 2. We see our KHS average, the global average, and the Texas average. All right, let's see. We did pretty good on this one. Let's see what made the kids do so well on this one. All right, for time between 0 and pi, a particle is moving along the curve, and as soon as I see that, in my mind shifts to all of our particle motion formulas. Speed, total distance traveled, velocity vectors, acceleration vectors, all of that they're all popping into my head. Slope, dy dx, dy dt over dx dt. All of those, excuse me. Oh my goodness, excuse me. All right. So they tell us position is x of t, y of t. X is not explicitly given. Y of t is 2 sine of t. And it is known that dx dt is e to the cosine t. All right, at time 0, the particle is at position 1, 0. So they are giving me that x at time 0 is 1. Y at time 0 is 0. Okay? They gave me dx dt. I really want dy dt, so I'm going to immediately find dy dt. Dy dt, if this is y of t, dy dt, the derivative of that is 2 cosine of t. All right? So I have all of those. Part A, find the acceleration vector. Okay? When I see that, I know what to do. So I'm going to come down here, and before I get started, so remember you guys, you're going to have the question booklet, and then you're going to have the answer booklet. Nobody is ever going to see your question booklet. They're only going to be able to look at your response booklet. So anything you write, like my little scratch mark up here, my little scratches, they're not going to see that. So I have to rewrite some of those things. So I'm going to recap. dx dt, they already told me, is e to the cosine t. Whoops, cosine t. All right, dy dt, I know, I just found it, is 2 cosine t. X of 0 is 1, y of 0 is 0. So that's on my response booklet. So now in part A, the acceleration vector. The acceleration vector at time 1 is, I need to say what I'm going to be doing. This is x double prime at time 1, y double prime at time 1. I know x prime and y prime. And no, you don't have to say that that is x prime and that is y prime. They know dx dt is x prime. It's just another notation for it. Okay? So, calculator we go. So I'm going to go into my calculator, clear out number 1, and go on to number 2 here. In for y1, I am putting x prime, e to the cosine t. In for y2, I'm putting 2 cosine t. Okay, double check. Every answer is going to have that in it, so double check to make sure that you put those in there correctly. Okay, home screen. I need the derivative. I need x double prime, so I need the derivative of y1 at time 1, and I need the derivative of y2 at time 1. So that will be, let me get rid of some of the glare maybe. Okay. Negative 1.444. Give more values after the decimal point if you want, but at least 3, right? Negative 1.6829 if you want to, but at least, so they would only accept this answer or a 3 back here. This is the only x coordinate answer that they would accept. Okay, part B. Did we show the setup for our calculations? Yes, we did. For time 0 to pi, find the first time t at which the speed of the particle is 1.5. Show the work that leads to your answer. So speed. Speed is square root x prime squared plus y prime squared. That is speed. We want to know when is the first time that that speed is 1.5. My calculator will do it for me. Gosh, all that glare. I'm trying to get there. Oh. I wonder. Okay. All right. Well, whatever. Okay. Yeah, it is good over here. All right. So I'm going to go down into y3, and I'm going to type in square root of y1 squared plus y2 squared. So I have speed in for y3. I'm going to put a 1.5 in for y4 because they told me to, practically. Turn off the graphs of y1 and y2 because we don't want to see those. Excuse me, I started coughing all of a sudden, had to pause it for a moment. Okay, I turned off the graphs of y1 and y2, and in my window, I'm going to go from 0 to pi because they told me to. For my y-min and y-max, I only need to make sure that it includes this 1.5. And 1.5 is between -4 and 4, so I'm just going to leave it like that. So there's the speed function. And there's 1.5. I see that it intersects twice. I want the first one, so I want that one right there. Second calc 5, enter, enter, enter. It gave me that one. So that's the time, 1.254. 1.254. All right. So part B is done. Part C, find the slope of the line tangent. That is dy dx. Okay, find the slope of the tangent line, dy dx. So dy dx is dy dt over dx dt in parametrics. We want to find the slope of the line tangent at time 1. So I'm going to come in and say what I'm doing. I want time to be 1. I want time to be 1. And I'm going to let my calculator go do the rest. Okay, so second quit. Okay, in for, I think I'm going to replace y4. I'm going to put slope in for y4. So I want dy dt over dx dt. That is y2 over y1. y2 over y1. Okay, so my slope is stored in for y4. So here I can just do y4 at 1. Okay, of course, as an alternative, you could have just done y2 at time 1 divided by y1 at time 1. And of course, it would give you the same value, the same answer. Okay, so 0.6295, 0.629, give more if you want to, but you have to have at least 3. So they would accept 0.629 and 0.630 in this case. All right, part D. Wait, we're not done with part C. Find the x-coordinate of the position of the particle at time 1. Okay, x-coordinate at time 1. We know the x-coordinate at time 0. We want the x-coordinate at time 1, so I set up fundamental theorem of calculus. X at time 1 minus x at time 0 is equal to the integral from 0 to 1 of x prime. Remember, you guys, whatever is here has got to come first. You've got to do it that way. The last test I graded, I had several people have one number here and a different number there. That is not fundamental theorem of calculus. Okay? So we want x at time 1. They told me that x at time 0 was 1. So x at time 1 is equal to 1 plus this integral, which is, that glare is killing me. All right. Okay, so, 1, let me clear that so you can see this. 1 plus integral 0 to 1 of y1. y1 is our x prime, right? So 3.341. Or they would also accept 3.342 because the next digit is a 5. Okay? Did I finish part C this time? Did I show the work? Yes, of course I showed my work. Okay, part D. Find the total distance traveled. And then I'm going to come up here and do part D. Find the total distance traveled by the particle. Total distance traveled. Integrate speed. Integrate speed. So the integral from 0 to pi of the speed function square root x prime of t squared plus y prime of t squared dt. Not optional. Okay. Total distance traveled. Total distance traveled. Integrate speed. So, math 9, 0 to pi of, do I still have that stored in? I do still have it stored in for y3. That's good. So I'm going to just put y3 over here, dt. 6.034, or they would also accept 6.035. But you are always welcome to put more numbers after the decimal point if you want. You must give at least 3. I keep saying that because I'm still seeing kids giving me 2 decimal places, and it's driving me bananas. All right, how did they score this question this year? Okay. For part A, they gave 1 point for x double prime of 1, and then they said with setup. You had to say what you were doing. Of course, that's always been the case. So is this answer correct? And did you say where it came from? And then 1 point for y double prime. They were very nice that year, giving us 2 points for such a simple little question. Okay, part B. 1 point was for the speed expression, and they wrote it out like this. In their answer, they wrote it out like this. 1 point for that. Did we show that? Of course we did. We did it right here. You don't have to write the functions because we wrote what they are up here. Okay? Oh, continuing, they said that to get this first point, you had to say that that was equal to 1.5. Okay? And then 1 point for the answer. Okay, part C, 1 point for the slope with supporting work. That's how they phrased it. One point for the integral from 0 to 1 of e to the cosine, I keep writing, cosine t dt. So 1 point for this integral right here. In other words, did the student know to use the fundamental theorem of calculus? Did they know to use it? And then 1 point for the x-coordinate of the position at time 1. Part D, 1 point for the integral, 1 point for the integral 1 point for the answer. I can see why my students did well on this one last year, that year, when I'm making it. It's this last year. Okay. Alrighty, so that was number 2.